Let's talk about heat transfer. What we're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the Earth, up in the atmosphere, or even out in space. Heat transfer occurs really in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This is heat transfer as a result of molecular contact. The best way to understand conduction is by thinking about an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has transferred throughout the entire material. Conduction is going to happen most effectively in solid materials. But let's not forget about convection and radiation. Let's look at convection. This is heat transfer through or as a result of density differences. Again, let's grab that match, and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this, and that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand. And when it expands, it becomes less dense than the surrounding air and therefore floats upwards. And with it goes some of that heat energy. That's what convection is all about. And this is going to occur most effectively within liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, heat is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves. And that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open, empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the key word that goes with each one. For convection, it's going to be density differences. For conduction, it's going to be contact. And for radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you're camping and you hold a pot of water or stew above that flame. Well, right now in this one picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at heat transfer.